Hi guys! Welcome again to my video. And for today, I will be discussing about differential equation involving partial and ordinary differential equation, order and degree, and the solutions of differential equation. So let's get started!
Let us define what is differential equation. When we say differential equation, it is an equation containing the derivatives of one or more dependent variables with respect to one or more independent variables. So I have here an example, y double prime plus 2y prime is equal to 3y. And we have different forms of how to write a certain differential equation, including one of those are function notation and Leibniz notation. So here it goes, a function notation and Leibniz notation. We have the second derivative of y with respect to x plus 2 times the derivative of y with respect to x is equal to 3y. So these three equations here are just saying or representing the same thing. They say, okay, can I find functions where the second derivative of the function plus 2 times the first derivative of the function is equal to 3 times the function itself. Okay, so let's proceed to identifying the dependent and independent variable. When we say dependent, it is the variable used in the derivative of a certain differential equation located in the numerator. And when we say independent variable, it is the variable located in the denominator that is used in the derivative of a certain differential equation. To understand that concept, I have here an example. First is the example. Derivative of y with respect to x minus 2x plus 15. So, we have here the variable y in the numerator, which is our dependent, and our independent variable is located in the denominator of the derivative of a certain differential equation. So, our dependent is y and dependent is x. Next example. The second partial derivative of y with respect to x minus the partial derivative of y with respect to x raised to 3 is equal to 0. So we have two derivatives here, this one and this one. So, since the variable that is used in the numerator of the two derivatives is y, so we have common variable y, and also for the denominator it has a common variable. So our dependent is y and independent is x. Okay, for the next example. So this example involves trigonometric functions, and we cannot easily identify what is the dependent and independent variable. So we'll divide this one into dx, either dx or dy. So first, we will divide this one to dx, and after that, we will divide this equation to dy. Okay, let's find out what will happen to this equation. Okay, if we will divide to dx, we can have this equation. Cos x plus sin y times the derivative of y with respect to x is equal to 0. And since this is only our derivative here, our variable used in the numerator is y. So this is our dependent. And for our denominator, the variable x is the independent variable. Okay, let's see if the equation will be divided into dy. So, we can have this equation, cos x times the derivative of x with respect to y plus sin y is equal to 0. So, since again this is our only derivative, so we can have the dependent variable x and our independent variable is y. So, since we have either of the two variables in the dependent and independent, so we can conclude that dependent could be x or y, or our independent could be x or y also. So for when we divide it into dx, we can have the dependent variable as y, and our independent is x. If the equation will be divided into dy, we can have the dependent variable x and our independent is y. Okay, so let's proceed to ordinary and partial differential equations. So these are the types of differential equation. So earlier we determined the dependent and independent variable, and it is very helpful in identifying what type differential equation you are into. So either ordinary or partial. So let's define what is ordinary differential equation so that you can understand clearly what I am talking about. When we say ordinary differential equation, it is an equation in which all the differential coefficients have different reference to a single independent variable. And when we say partial differential equation, it is an equation which contains two or more independent variable and partial derivatives denoted by the symbol this one. Okay, I have here an example to clearly conceptualize or understand what I am talking about here. First example, 5y prime squared plus 10 times y prime raised to 3 is equal to 3x minus y. So since we cannot easily identify the dependent and independent variable here, we will apply our knowledge about rewriting a certain differential equation into Leibniz notation. We can, here it goes. 5 times the second derivative of y with respect to x squared plus 10 times the derivative of y with respect to x raised to 3 is equal to 3x minus y. So in this kind of equation, we can easily identify the dependent and independent variable na. So our dependent variable is y and our independent variable is x. So since we have a single independent variable here, example number 1 is an ordinary differential equation since it has a single independent variable. Okay, let's proceed to the next example. 5 times d squared, 5 times the second derivative of v with respect to x plus 6 times the second derivative of v with respect to y is equal to 0. So in this kind of equation, we don't need to rewrite this one because we can easily identify na the dependent and independent. So our dependent there is v and our independent are x and y. So we can conclude that this example number 2 is partial differential equation since it has two independent variable. Okay, so let's proceed to the solutions, the order and degree of differential equation. Okay, so let us define what is the order and the degree. Order first. Order of differential equation is defined as order of the highest or largest derivative in the given equation. And when we say degree of differential equation, it is the degree of the highest or largest derivative occurring in the equation after the equation has been expressed in a form free from radicals. So, again, to clearly understand the concept, I have here examples. First example, the second partial derivative of y with respect to x minus 6 times the partial derivative of x with respect to y plus 5 is equal to 0. So, we have, in identifying the order, we'll locate the derivatives. We just consider the derivatives lang ha. So, we have two derivatives here, this one and this one. So, since this one is the largest derivative, so and it is the second derivative, so our order here is 2. And our degree the degree is the exponent of the highest or largest derivative. So, since this is our largest derivative and it is raised to 1, so we have imaginary 1 here. So, the degree is 1. Okay? So, let's proceed to the next example. The second partial derivative of y with respect to x minus the partial derivative of y with respect to x raised to 3 is equal to 0. And we have the largest derivative here. Na 3 ha? Baka 3 yung answer nyo since 3 is the largest number here. No, it is wrong. Because 3 here is just the exponent of the our smallest derivative here. And this is our largest. Okay? So then don't be confused about that, guys. Okay, so next, since this is our largest derivative, so our order is 2 and our degree, since it is raised to 1, we have imaginary 1 there. So is 1. After discussing about the types, which are the ordinary, partial, identifying the dependent and independent variable, and the order and the degree of differential equation, we will proceed now to the solutions of differential equation. I have prepared 3 examples only. So, first example, xy prime plus y is equal to 0. And show that y is equal to 1 over x is a solution to the given differential equation. So we will verify that this given solution will satisfy to our differential equation. Okay, this is our given solution. Y is equal to 1 over x, or we can rewrite that one to y is equal to x raised to negative 1 so that we can easily get the derivative. Okay, since our differential equation here is first degree only, or first derivative only, we will also get the first derivative of our given solution. Okay? So this is our first derivative, negative x raised to negative 2. Or we can rewrite that one to negative 1 over x squared. And after that, after finding the derivative of our given solution, we'll plug in the values to the differential equation. So, x, we'll write the x, and plug in the value of our first derivative, which is negative 1 over x squared, plus y, our y, plug in the value of y, 1 over x is equal to 0. And we will do the math. We can have negative 1 over x, since x and x will be cancelled here. We will left with negative 1 over x plus 1 over x is equal to 0. And that would be cancelled, and therefore y is equal to 1 over x is a solution to the given differential equation. Okay? Okay, that's how you will verify or show that the given solution of a certain differential equation. Okay? Okay, next example. Show that the solution of the differential equation, the second derivative of y with respect to x, plus 4y is equal to 0, is y is equal to c sub 1 sine 2x plus 3 cos 2x. So, we'll verify again if this given solution will satisfy to our differential equation. So, okay. Again, since this is our given solution. So, since our differential equation is in the degree of second derivative, so we will get also the solution, we will also get the second derivative of our solution. So, our first derivative, 2c sub 1 cos 2x minus 6 sine 2x, and our second derivative, negative 4c sub 1 sine 2x minus 12 cos 2x. And again, we'll plug in or substitute all the values to the differential equation. Okay, so our second derivative, ito, negative 4c sub 1 sine 2x minus 12 cos x plus 4, and we'll plug in the value of our y, c sub 1 sine 2x plus 3 cos 2x is equal to 0. And we will do the math here. So, copy lang to distribute. So, 4c c sub 1 sine 2x plus 4 times 3, 12 cos 2x. And ito, nakikita na natin na may makaka-cancel. So, cancel yung dalawa. And ito naman. So, 0 is equal to 0. So, na-verify na natin na ang given solution is the solution of the differential equation. Okay? Okay. So, let's proceed to our next and last example. So, verify that y is equal to e raised to negative 2x is a solution to the differential equation y triple prime minus 3y prime plus 2y is equal to 0. So, we have here the solution. It is our given ha. Baka makonfuse kayo. Ito, given lang siya. And since our differential equation is in the third derivative, so we'll also get the third derivative of our given solution. First derivative, we have negative 2e raised to negative 2x. And our second derivative, 4e raised to negative 2x. And for our third derivative, negative 8e raised to negative 2x. Again, we will plug in, substitute, or ano ba yung term na yan? The values to the differential equation. Okay. Negative 8, e raised to negative 2x minus 3. Minus 3, ito ha, the third derivative, ito, plug in na siya. And minus 3, then, plug in our value of the first derivative, which is negative 2e raised to negative 2x, plus 2, and plug in again the value of our y, e raised to negative 2x is equal to 0. Again, we will do the math. So, negative 8e raised to negative 2x plus negative 3 times negative 2. So, we have positive 6e raised to negative 2x plus 2e raised to 2x. Negative 2x. Okay, we'll combine like terms. So, we can have this equation and we can see that makakancel na to siya. And we arrive at our goal, which is 0 is equal to 0. Therefore, y is equal to e raised to negative 2x is a solution of our differential equation y triple prime minus 3y prime plus 2y. Okay? So, I hope you learned something about our discussion for today, and that would be all. Thank you!